Good afternoon, everybody, and welcome to this month's webinar entitled, Oh, the Places You'll Go, the Future of Lab Informatics. So before we get started, a few words about myself. I've been in the informatics arena for over 25 years, both within the lab and manufacturing. Within the lab, I've had exposure to various different types of labs, from clinical, R&D to QC, and I have been exposed to a wide variety of different lab informatics systems, including LIMS, ELN, CDS, and SDMS. Within the manufacturing space, I've also been exposed to ERP systems, MES systems, manufacturing execution systems, and EBR systems, electronic batch record systems. I have worked across a number of industries during that time frame, including pharma, biotech, chemical, petrochemical. Okay, that's enough about myself. Let's quickly review what we're going to attempt to do in this 45-minute webinar. So what we're going to be doing is we're going to be looking at some of the major innovations in science, innovations in automation in general, and the introduction of new black box devices, and also innovation in technology. And we're going to look at each of those and see the impact that that innovation has had on lab informatics space. We're also going to look at changes in regulations, guidance, and laws, and the commercial pressure that is on all companies these days to produce more with less. And then finally, in Where Are We Now, we're going to have a look at the lab informatics space to see where major vendors are positioning themselves both for now and into the future. And then finally, what we're going to do, we're going to peer over the horizon and look into see what the future may bring in the lab informatics space. So first thing, science, and I've just picked upon a couple of topics within science which interest me, and which I'm sure that the vast majority of you are aware of. And the first one here is genomics, and perhaps the greatest achievement, scientific achievement anyway, of the early 21st century is the sequencing of the human genome. So the Human Genome Project was an international scientific research project with the goal of determining the sequence of chemical-based pairs which make up human DNA, and also of identifying and mapping all of the genes of the human genome. This was an endeavor that took place over a period of 13 years. It was international in scope, with research institutes from the US, China, Australia, UK, other parts of Western Europe, all working in collaboration to achieve this goal of the sequencing of the human genome. It was completed in 2003, took a total of 13 years, at an estimated cost of $2.7 billion. And why is this important? Well, it's important for a number of reasons, but for the sake of this webinar, we're going to focus on the fact that virtually every human disease has its origin in genetics. And by understanding our genetics, we will be able to diagnose disease more effectively, be able to prescribe specific treatments based upon the diagnosis that we've made, and all of which should result in more cost-effective health care. So major change there, a major innovation within the scientific community. Moving to the other extreme, and probably, even though at a smaller scale, just as important, is we've made major advances in our ability to detect pathogens. And pathogen detection is of critical importance in many fields, including food safety, clinical research, drug discovery. animal health, and forensics. And what's happened over the last few years is we've developed a number of techniques for rapid, sensitive, and specific detection of pathogens. And what we've really done is we've moved away from the traditional cell culture techniques that often took several days to a week or more to get the final results from, to ELISA techniques, and then on to PCR and molecular RNA techniques. And with each advancement, we've been able to reduce the time for test results, and we've been able to increase the accuracy of the results that are produced. And finally, we've also been able to simplify the use of these techniques, meaning it is easier for an analyst to perform than the old-fashioned time-consuming techniques. So obviously there's been many other innovations in science, but I just want to focus on these two for right now and look at the overall impact of the science, the innovations in science and what they have meant to lab informatics.